Hi, today we are going to learn about plane geometry 1. With the knowledge of plane geometry 1, we can also learn plane geometry 2, popularly known as circle theorem. So, plane geometry 1 first. Plane geometry 1. The first thing we are going to learn in plane geometry 1 is right angles. Right angles. In right angles, the total sum of the angles is equal to 90 degrees, and the lines are perpendicular to each other. So this is line AB. So line AB should be perpendicular to line AC. So when line AB is perpendicular to line AC, then we call it a right angle. So these two lines are perpendicular to each other and they form right angle. They form a right angle. So the total sum is 90 degrees. So let's look at this question. In the diagram below, this is the diagram. Find x. So this line is perpendicular to this line. So they form a right angle. So the angles in a right angle add up to what? 90 degrees. So we are going to sum, so we are going to add the total angles here and equate it to 90 degrees. So we are going to have x, which is this one, plus 60 degrees, which is this one. The total sum should give us 90 degrees. So we are going to make x the subject. This is x. Making x the subject means we want to make x to stand alone. We're going to have x is equal to 90 degrees minus 60 degrees. So x is equal to 90 minus 60 is 30 degrees. So therefore, the angle here is what? 30 degrees. So therefore, x is equal to 30 degrees. The next thing we are going to learn about is angles at a point. Angles at a point. Angles at a point. Angles at a point add up to 360 degrees. For example, if we have this diagram, this is alpha, B, and C. A, B, and C. We are going to find the angles at a point. This is the point. So angles at a point add up to 360. So we are going to have A, this angle, plus this angle, plus this angle. So give us what? 360 degrees. So angles at a point add up to 360 degrees. Let's take this question. Find the value of x in the diagram below. Find the value of x in the diagram below. So this is angles at a point. You can see this one, angles at a point. So we are going to add these three angles, 1, 2, 3, and equate it to 360 degrees. So we are going to have 2x plus 30, 2x plus 30. We'll add it to x plus 10, x plus 10. Then we'll add it to 4x minus 30. We'll add it to 4x minus 30. Everything should give us 360 degrees. 360 degrees. That's the first step. Now we are now going to add 30 plus 10 minus 30. So 30 plus 10, which is 40, minus 30, which is 10. So we are going to have 10 plus 10 plus. We have 2x plus x plus 4x. So 2x plus x is 3x plus x, which is 6x. So plus 6x is equal to 360 degrees. So we want to make x the subject. So we'll make 7x to stand here. Then we have 360 minus 10. So 7x is equal to 350 degrees. We divide both sides by 7. We divide both sides by 7. So we are going to have this 7 will cancel itself 1, 1. So we are going to have x is equal to 7 to itself 1 to 35, 5. So x is equal to 50 degrees. So that is the value of x. The next thing we are going to look at is angles on a straight line. 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 Angles on a straight line add up to 180 degrees. So as we can see here, this angle A, this angle B, and this angle C are all on this straight line. So all the angles on a straight line add up to 180 degrees. So to find the missing letter, we are going to have A plus B plus C to give us 180 degrees. Angles on a straight line add up to 180 degrees. Okay, so let's look at this question. Find the value of x. So we have 30 degrees, we have 70 degrees, and we have x. So we are supposed to find this x. These three angles, 1, 2, 3, are on this straight line. And angles on a straight line, they add up to 180 degrees. So we are going to have 30 degrees plus 70 degrees plus x is equal to 180 degrees. We are going to make x the subject. So we group like terms. So 30 plus 70 is 100 degrees plus x is equal to 180 degrees. We want to make x the subject. So we bring x here. X is equal to 180 degrees minus the 100 degrees. So x is equal to 180 minus 100 is 80 degrees. Therefore, x is equal to 80 degrees. Let's look at this one. We should find y. So angles on a straight line add up to 180 degrees. We are going to have 20 degrees plus 70 degrees plus y to give us 120 degrees. So we are now supposed to simplify this one. So 20 plus 70, 90 degrees plus y is equal to 180 degrees. Y is equal to 180 degrees minus 90 degrees. So y is equal to 180 minus 90 is 90 degrees. So therefore this y is 90 degrees. So let's learn angle properties. Let's learn angle properties. We have a lot of angles here. We have line AB, we have line CD. These two lines are parallel to each other. These two lines are parallel to each other, which means they will never meet. So this line is going, this line too is going, so these two lines will never meet. These two lines will never meet. So we are going to look at corresponding angles and alternate angles. For alternate angles, we have the Z shape. So the first thing we are going to look at is alternate angles. That is the Z shape. Alternate angles. So alternate angles, the corners of the Z are the same. This is Z2. The corners of the Z or the Z are the same. So if here is 1, here too is 1. If here is 5, here too should be 5. So alternate angles are equal. So they alternate. So when you come here, when you look at this angle properties, we can find Z shape here. So we have from A, we come to this point, we come here, we come here. So this is Z shape. So C and F are equal. So from alternate angles, C and F are equal. C and F are equal. That is alternate angles. Now the next thing is corresponding angles. Corresponding angles, which uses the F shape. Which uses the F shape. Whatever that is on top here, the angle here is equal to the angle here. The angle beneath this one is equal to the angle here. I take that again. Corresponding angles. The angle on top here is equal to the angle here. And the angle beneath this line is equal to the angle here. So when you come here, we can have the F shape here. We have this, and we have this. So the angle on top here is equal to the angle on top here. The angle beneath here is equal to the angle beneath here. These are called corresponding angles. These are called corresponding angles. So the angle here is the same thing as the angle here. The angle here is the same thing as the angle here, because we are having the F shape like this from the B to this point down here to the D. So this is F shape. We can also have another F shape this side. It doesn't matter the direction of the F or the Z. So we have from A to this point down here into the C. This is F. Then the top angle here is equal to here. The down angle here is equal to here. So when we are going to use the alternate angles, we have C is equal to what? F. So C is equal to F. C is equal to F, and D is equal to E. D is equal to E. We can also have another one like this. So D is equal to E. D is equal to E. So these are alternate angles. So this angle alternate with this angle too alternate with this. When you come to the corresponding angle, the F shape, so H is equal to D, F is equal to B. When you come this side, G is equal to C, E is equal to A, or A is equal to E. That is it. So these are the properties of parallel line. The properties of parallel lines. Properties of parallel lines. So angle properties of parallel lines. Angle properties of parallel lines. Okay, let's look at this question. This is the diagram. We have 40 here. We have A, B, and C. Find A, B, and C. So we are going to find the value of A, that of C, and that of B. So we are going to use angle properties of parallel lines theorems to what? To get A, B, and C. So let's start with alternate angles. Angles that alternate, the Z shape. You see that this is a Z shape. So the angle here is always equal to the angle here. So for the Z shape, you see that C is equal to 40 degrees. When we also want to use corresponding angles, the F shape, this is the F shape too. The angle on top here is also equal to the angle on top here. The angle beneath here is also equal to the angle beneath here. So A is also equal to 40 degrees. Now it is only this. We are left with B. How do we get B? To get B, B and A are angles on a straight line. Angles on a straight line. So angles on a straight line add up to 180 degrees. So when we add A and B, we should get what? 180 degrees. But now we know A, which is 40 degrees. So angles on a straight line add up to 180. So this is the A and B on a straight line like this. So we are going to have A plus B should give us 180 degrees. So A is 40 degrees plus B, which is equal to 180 degrees. We want to make B the subject. We are going to have B is equal to 180 degrees minus 40 degrees. B is equal to 140 degrees. So let's look at the triangle. Let's look at the triangle. The triangle has three sides. One, two, three. The triangle has three sides. One, two, three. So the interior angles means the angles inside. We can have an exterior angle here. We can have an exterior angle here. But here we are referring to the interior angles, X, Y, and Z. So the interior angles of a triangle add up to 180 degrees. So the total sum of the interior angles is 180 degrees. So which means X plus Y plus Z is 180 degrees. So let's look at this triangle. We have 70 degrees here, we have 30 degrees here, and we have X. How do we find X? We are going to add the interior angles of this triangle to 180. So we have 70 degrees plus 30 degrees plus X to give us 180 degrees. So 30 plus 70 is 100 degrees plus x is equal to 180 degrees. So x is equal to 180 degrees minus 100 degrees. So x is equal to 80 degrees.